Okay, so this video is about average rate of change. Average rate of change basically means slope. As a formula in math and physics and calculus, we usually write it as delta y divided by delta x. Delta basically means change in. So change in y divided by the change in x. So you probably learned slope at first as y sub 1 subtract y sub 2 divided by x sub 1 subtract x sub 2, or vice versa. It could be reversed, y2 subtract y1, x2 subtract x1. Either way, it represents the slope. So the change in basically means the difference from one y value to the next divided by the difference from one x value to the next in those two coordinates. So that's what delta means. It means change in. All right, so let's look at that. I'm going to erase this. So if you need to know what delta means and so forth, you can copy all that down. I'm about to change this screen. Okay, let's talk about how to find the slope here. This function is the function y equals x squared. So this is the function here, y equals x squared. You've probably grabbed that function many times before. And let's say we wanted to find the slope at point 1. So, second. All right, so the direction would be find the slope of y equals x squared at this point, coordinate 1, 1. So if we want to find a slope, I need another point. So if we got to approximate it, I need a second point. So a second point I could use that's on this curve, I could use where x is 3. And then the output there is 9. So I got two coordinates. I got a slope, I got a coordinate 1, 1, and I got a coordinate 3, 9. The line looks like this. The line that connects the two looks like this. So this line here. So if I got 2 points, 1, 1, and 3, 9, I can approximate the slope at this point by using those coordinates. So the change in y divided by the change in x should equal to, subtract the y's, 9, subtract 1, and then subtract the x's, 3, subtract 1. So that should be 8 over 2. So the slope is about 4. But 3 is a good bit away. I probably can get a better approximation had I chosen number 2 instead of going all the way out to 3. We got closer to it, like if I chose the number 2, I probably have a better approximation. So let's try that. So if I go over to my table, type in 2, output of y equals x squared at 2 is 4. So we got a closer coordinate. And this is the point right here. I'll show its line now. So this is the line that connects point 1, 1 to point 2, 4. And I want to find the slope of that line. So I'll use these two coordinates. So it looks like the coordinates disappeared. So one of the coordinates was 1, 1. Other coordinate was 2, 4. So if I want to find the change in y with change in x, so that will wind up being 4 subtract 1 divided by 2 subtract 1. So a better estimate will wind up being 3 over 1. So my first estimate was 4. Now, as I get closer to it, my approximation is about 3. I think you see where I'm going. The closer I get to 1, like the shorter I can get the distance to be, the better approximation I'm going to get for the slope of the line right there at 1, 1. So I really want to choose numbers really, really close to 1. So if I think about numbers really, really close to 1 for the x, I might be thinking like 1.01. Or in this direction, you might think, well, just smaller than 1 is like 0.09 or 0.099. That'd be numbers just to the left of 1. So let's try those coordinates. All right. So 0.99. So I got a coordinate 0.99 and 0.98. I'm trying a coordinate just to the right of 1, so I'm trying 1.01. So it's really, really close. I mean, it's like 0.100 of a decimal from 1. So now I got two coordinates. I got two coordinates very close to that coordinate 1, 1. Let's actually try to find the slope there now. So right here, you notice the points are so close together, they don't even show you. It's like they're that close. They basically is within the red dots. So the first coordinate is 0.99 and comma 0.98. So this is coordinate 0.99, 0.9801. And this is the coordinate 1.01, 1.0201. So considering those two coordinates, we'll first subtract the y value. So let me start with the bigger number, 1.0201, subtract 0.9801 divided by 1.01, subtract 0.99. Put in your calculator, you should get 0.04 divided by 0.02, and that's 2. So as I get really, really close, the slope basically winds up being 2. Right there as I get really, really close to 1. So if you want to find the slope at a specific point, you really want to choose numbers really, really close to that point, and then find a slope there. That gives you a better approximation. But truthfully, we can go even further. I mean, we have to stop at 0.99. We could put in 14 nines there to get really, really close to 1, or 13 zeros there, and then get really, really close to 1 on the other side. So the closer and closer we get, the shorter that distance is, the more accurate our answer is going to be. And that leads us to a limit. So this is the definition we'll look at next. Oh, but to answer the question, the slope is about 2. All right. So considering our last function, this is a picture of it. And in this picture, we're looking at y equals x squared again. And basically what we decided was, as closer and closer we get to the place where x is 1, the closer and closer that distance is, the more accurate our slope is. At that point is. Slope at that point is. So if we're looking at this, this formula actually uses the letter h. A lot of calculus books use the letter h to represent the distance from 1 that we're going to be considering. Like I use 0.01 as a distance, but basically it's whatever h is. So whatever that value is, we're going to say, well, if it's 1, we're going to add h to it. So h could be 0.01, 0.001, 0.00001, and so forth. The more zeros, though, you get that follows the 1, the closer and closer you actually get to 1. So basically, we'll define the limit there, or the slope there is this. So the slope there is essentially changing y or changing x, and we'll find the y value, so f of 1 plus h, subtract f of 1, divided by the change in x, which essentially is h. So that leads us to a new limit. So basically we can say the slope of a curve, y equals f of x, at a point, whatever the input is for x, is f of that input. So whatever x and y are, they're related to each other. Whatever you plug in for x, the output when you plug in that x is y. So the slope would always equal to the limit as h approaches 0. So again, as this h gets smaller and smaller and smaller, it can eventually give us the slope. So the slope is going to be the limit as h approaches 0 of the a plus h, f of a plus h, subtract f of a divided by h. So it's the 2 points divided by the change in x. So we're basically going to find that limit, and that's actually the formula. This is actually called the definition of slope at a point. This is kind of important. I'll get that copied down someplace. That's called definition of slope at a point. All right, moving on. Let's look at this graphically. Finding this limit graphically and algebraically. So the problem says, find the slope of the function f of x equals x to the 4th plus 5x at the point 226. This must be on the line, apparently, on the curve, using the definition of slope formula. The definition of slope formula says this. The limit is as h approaches 0 of f of a plus h, subtract f of a divided by h. Now, in this case, we know a. A is 2. That's the x value you're going to plug in here. So a is 2. So we know that for sure. So we're going to plug this in as f of 2 plus h, subtract f of 2 divided by h. Now, in order to find out what f of 2 plus h is and so forth, we got to plug this 2 plus h into this formula. So this is what we should have. I'm going to need some more space to do some computation. So if you want to write down this question and pause the video, I'm going to erase most of it and rewrite the limit. So here we are. Okay, since f of x equals x to the 4th plus 5x, then f of 2 plus h should be 2 plus h to the fourth plus 5 times 2 plus h. And f of 2 apparently is 26. Let's make sure that it should be 2 to the fourth plus 5 times 2. And this is the easy one. That's 16 plus 10 is definitely 26. This requires a little work. So what we right now have is the numerator should be, let's write it. Numerator should be 2 plus h to the fourth plus 10 plus 5h. Subtract f of 2, so that's 26. And that's going to be divided by h. I can clean it up a little bit. 10 and 26 adds up, so I'm going to rewrite that as the limit as h approaches 0 of 2 plus h to the fourth plus 5h subtract 16 divided by the letter h. So what we want to find out is, we want to find out what happens as h approaches 0. So we want to plug in numbers closer and closer to 0 for h. I'd rather do that with the graph. I'd rather not do that by hand. So let's actually graph this in Desmos. So pause the video and copy whatever you need. I'm about to leave the screen and go to Desmos. So what we're looking for is a limit there. So we're looking for the limit as h approaches 0. So Desmos gives you the option of deciding what h is. And I'm going to make my h really close to 0, like 0.1. And it tells you, I don't know if you guys can see that, but that says 39.481, which I can make that more contrast. But it says 39.481. If I try it closer than 0.1, like 0.01, you get, it looks to be a roughly 37.24. So I want to get really, really close to 1. So I'm going to put in about 4 zeros. 0.0001. And if you notice, it's getting closer to 1. So it's getting like 37.0002. So I'm thinking that slope there is probably 37. I'm plugging some more zeros. And as I plug in more and more zeros, I get more and more zeros after 37. So it looks like the slope, as h approaches 0, it looks like that slope is approaching 37. So I know the slope there by using a table of values. I know the slope there must be about 37. All right, so let's talk about a different type of example. But I will make sure you answer the question. So to answer the question is the slope at, well, I'll write it out. So the answer is the slope at 226 is about 37. All right, moving on. All right, so I actually graphed this function already. It says find the average rate of change of this function, x cubed subtract x, on the interval, over the interval, -1 and 2. So this is where x is -1, this is where x is 2, and you want to find the average rate of change on that interval. So I need the coordinate here, I need the coordinate where it meets 2. So it meets 2 right there. That's coordinate 2, 6. That's coordinate -1, 0. So those are my two coordinates. Make a line connected. So my change in y divided by change in x should be 6 subtract 0 over 2 subtract -1. I don't know why I put parentheses there. It's 6 over 3. Apparently that slope is 2 from one point to the next on that interval. So whenever they give you an interval with endpoints there, you basically find the coordinate at both endpoints and then find the change in y over change in x, or the slope there. And that gives you the average rate of change over that interval. All right, so I think that's pretty much it. I think that pretty much covers it all. One last example, though, on algebra of it. But I do have one last example on the algebra of it, but I won't talk about the algebra of it in this video because I only have 40 seconds left. So with that being said, that's all I have. Good luck.